Good morning, class. Today's Tuesday, so we're going to get started on today's lesson. We'll start with rounding.
Morning, third graders. If you remember, we like to start in that tens column and then we'll go to the hundreds column. I hope that you're remembering some of your methods. We're going to use the bully method this morning as we round these numbers. Rounding to the nearest 10, we need to find our tens place. Look at the bully. He's an 8. Is he big enough? Yes, he only has to be a 5. He's going to lift me up to an 8. And what happens to my friend? I protect him so he stays the same. Whatever happens to that old bully? Nothing ever happens to that old bully. 680. Moving on down, we have 298. I need to find my tens place. There it is. Look at your bully. Is he 5 or bigger? He sure is. He's going to lift me up. But this time I'm a 9. How do I get lifted up if I'm a 9? I look next door and I'm going to look at the number 29. 29 is going to lift up to a 30. And whatever happens to that old bully? Nothing ever happens to that old bully. Looking down below, here's my tens place. Here's my bully. Is he big enough? Yes, he is. He's going to lift me to a 1. What happens to my friend? I protect him. What happens to that old bully? Nothing ever happens to that old bully. 310. 305 rounds to 310. Now rounding to the nearest 100, the only thing I need to change is I am going to look at the hundreds place this time. So I have a 6 and my bully is now a 7. Is he big enough? Yes, he is. 6 is going to be lifted up to a 7. What happens to that old bully? Nothing ever happens to that old bully or his friends. This time I'm going to be a 2. The hundreds place is a 2. Is the 9 big enough? Yes, he is. He's going to lift me up to a 3. What happens to that bully? Nothing. Nothing ever happens to his friend. And lastly, I'm going to find the hundreds place in 305, which is a 3. Look next door. Is he big enough? Nope. He's not big enough. He's only a 0. What happens to me? He's not big enough to lift me up. I remain a 3. Nothing happens to the bully or his friends.
Okay, we're going to move right on to the next one. It says there are 48 cookies at the holiday party. 8 of the party guests are going to share the cookies. How many cookies will each guest receive? So what are we going to have to do? What's a key word in there? What are we going to do?
I see the word each.
Each. So let's look at that. Each can also mean to multiply or divide. But we're taking 48 and we're going to divide it up into 8. So we're going to be getting smaller.
We're also sharing those cookies,
yes.
So we know that we're going to have less cookies. So 48 divided by 8. How would you do that, Miss Powell?
Well, we look at backwards multiplication. We want to say what times 8 equals 48. And that helps us to, because we know that division is backwards multiplication, or multiplication is backwards division.
So if we started adding up 8 over and over again, we would eventually get to 48. Mm-hmm. How many times should we add 8 up to get to 48?
Well, if I knew my multiplications, we could just do that if we know our capital. We could say 6 times 8 is 48.
So 48 divided by 8 must be
6.
And we need a label. What are we talking about?
We're talking about cookies.
How many cookies? All right, moving on.
What is quotient?
Quotient means the answer to a division problem.
So we can look at those problems and I like to look at them backwards and solve them by multiplications, because by this time of the year we should all know our multiplication tables. 28 divided by 7 is
4.
66 divided by 11 is
6.
Because 6 times 11 is 66. 60 divided by 6 is?
I see a 0. That helps me know that it's 10.
10 times 6 is 60. 56 divided by 8.
5, 6, 7, 8. 56 is 7 times 8.
Good job.
All right, today we're going to be drawing a fraction that's equivalent to 1/4. That word equivalent stands out to me, Miss Powell. It's a fancy word, but what does it mean?
It means equal or the same.
Equal. So I'm going to have to think about this fraction looking the same as this fraction when we're done, but this one has 1 out of 4 pieces shaded. So I'm going to go ahead and cut this one into bigger or more slices. The slices actually got smaller as I cut my pizza. So how many slices do I have here?
Oh, we have 1, 2. We can count them 1, 2, 3, 4, 5, 6, 7, 8.
So if I cut this circle into 8 slices,
and that will be our denominator. That's our total number of slices.
How many pieces should I color to make it look exactly the same as that one?
2.
2. 1, 2. So that would be 2 out of 8. Those are equivalent fractions. Could there be more answers, Miss Powell?
Yes, there could be more answers.
There could. I could have cut this into even smaller slices, and I could have kept getting smaller and smaller. We're not going to do that for you today. This is the first one we came into, and that's the one that we expect you probably found also.
Buddy the dog ate 1/3 of a bowl of food. Freddie the dog ate 1/4 of a bowl of food. Who ate more food? So we're looking for what?
We're looking for the bigger one. We want to know what fraction is bigger, 1/3 or 1/4.
We could do this by the butterfly method or cross multiplying if we want to
We
do
could.
that.
Or we could also draw a picture.
Yes.
And so if we did the cross multiplying, we would go 4 times
1 is 4.
is 4, and 3 times 1 is
3.
So which one's bigger, 3 or 4?
The 4 is bigger, which is 1/3.
That's this side of the fraction, so 1/3 is greater. If I were to cut a piece of pizza, I would need to cut it into 3 slices, and over here I would cut it into 4 slices. I would color 1 piece over here and 1 piece over here, and this one is a bigger piece. 1/3 is greater than 1/4. We're skipping that box. We did it yesterday, if you remember. And so now we're moving on down to 4 snack. Carlos is eating a banana and a bowl of grapes. The banana has a mass of 75 grams, and the grapes have a mass of 48 grams. What is the total mass of Carlos's snack?
I see a key word in there.
What'd you find?
Total.
Total means add. So we're going to be adding some bananas weight up with some grapes weight.
So we have 75 plus 48. Does it matter what order we write those in?
It's an addition problem, so it really doesn't matter, but I like to get in the habit of putting the big number on top.
Very good habit to be in. So we have 5 plus 8 is 13. Carry your 1. 7 and 1 is 8. Plus 4 is 12.
So we need to label that. 123, what are we talking about here? It says what is the total mass, but mass means that we're measuring weight.
Grams.
So we're looking at grams. All right, we've got another one of those perimeter and area problems. We need to decide what the perimeter of this shape is and the area of this shape. Perimeter is a word that means the fence or the outside of a figure. Area is how many squares I can stuff inside of it. So typically area has a formula, Miss Powell. Can we use our formula today?
Yes, we can. We're going to have to do it, break it into parts because we have a shape, an L-shaped figure. And area is length times width. So this is it's more than one step to get the answer for this. So again, we want to show our work so we can break it into parts.
So you're saying I can only use the area formula if I have a rectangle or a square.
Yes.
And I don't have those until I cut it. So where should I cut it at?
I think we should cut it across a horizontal line right there. Horizontal is another word. We talk about horizontal.
If I cut it right there, I'm going to get rid of some unnecessary numbers. And an easy way to do that is to go to the end of my lines. So as I travel across that line I just drew, I'm going to circle this number right here. It's unnecessary. And I'm going to go to the other end of that line and circle that number. It's unnecessary because it doesn't help me find the length or the width of my two rectangles that I made. So area equals length times width. Let's look at this top rectangle. I just colored it red. What is the length of that one?
7.
And the width?
Is 2.
7 times 2 is?
14.
14. And now we've got to find the bottom area, the rectangle on the bottom. What is the length of it?
The length of it's 1.
1. And the width is?
7.
9.
Oh, 9. I missed
that one. Remember how it's unnecessary.
Yes, I was not looking.
And so 1 times 9 equals?
9.
9. And so we've got 9 centimeters and 14 centimeters squared. So how do I find the total centimeters squared?
We're going to add them up.
14 plus 9. Let's come over here. I wrote that kind of funny. 14 plus 9. 9 plus 4 is?
3. 13. Carry your 1.
And 1 plus 1 is?
2.
23 centimeters squared. Because we're counting the number of squares we could stuff inside of those figures. All right, perimeter. Let's look at the fence this time. We don't want Sparky to get out of our L shape, and we need to go buy some lumber. So here we go.
We're going to have to add all the sides. Add every side to get our perimeter.
8 plus 2
is 10.
Plus 7.
17.
Plus 7. 24.
24.
Plus 1.
25.
Plus 9.
34.
34 centimeters. So if I were going to the store, I would need to go and purchase 34 centimeters of lumber to keep Sparky inside.
That wouldn't be a very big pen for Sparky.
It sure wouldn't. Sparky must be a little bitty dog.
All right, guys. We will talk with you again tomorrow, and it will be Wednesday for your next lesson. Don't forget your assignment at the bottom of this practice, and we hope you're doing well. Thank you. Bye-bye.
Bye-bye, guys.